Chapter 2, Section 5, Proving Statements about Segments. Theorems and Proofs. A true statement that follows as a result of another true statement is a theorem. All theorems must be proven. You can use a two-column proof which has numbered statements and reasons that show the logical order of an argument. Properties of segment congruence are the reflexive property of segment congruence, which says that for any segment AB is congruent to AB, or for any segment, it is going to be congruent to itself. You've seen the reflexive property before with just variables, but now we can say that it is true for segments also. Symmetric property of segment congruence says that if AB is congruent to CD, then CD is congruent to AB. So it doesn't matter what order you write them, they are still congruent to each other. And the transitive property of segment congruence says that if AB is congruent to CD and CD is congruent to EF, we can say that AB is congruent to EF. So we can drop the CDs and set AB congruent to EF. You've seen the reflexive, symmetric, and transitive properties before. Now we are just applying them to segments. A two-column proof example says that you are given EF equals GH, and it asks you to prove that EG is congruent to FH. When we're writing a proof, a two-column proof, we're going to have statements on the left side and reasons on the right side. You always start a proof with what you are given. So I was given that EF equals GH, so number one statement is going to be just my given repeated. So I'm just going to say EF equals GH, and the reason for all of your givens is going to be given. The reason why you know that is because it was told to you, and if it is given, then we're going to take it as a true statement. If you look at the segment that they give us, we're trying to prove that EG is congruent to FH. If you notice, EG would be segment EF plus segment FG, and then segment FH would be segment GH plus segment FG. Notice that both of these segments are sharing the segment FG. Because they're both sharing the segment FG, for segment EG, I have my given EF and the segment FG. For segment FH, I have my given GH plus the segment FG. So from statement number one, I am going to add FG to both sides. Remember, when you add the same thing to both sides, it is the addition property of equality. Now, if we're talking about segment EG and segment FH, we're going to have to think back to what we've previously learned, and we know that the segment addition postulate says that EG would equal EF plus FG, and FH would equal GH plus FG. Notice that in 3, we have EG equals EF plus FG. Well, EF plus FG is the left side of my equation on 2, in statement 2. And then if you look at FH equals GH plus FG, notice that GH plus FG is on the right side of my equal sign on statement number 2. So this was the segment addition postulate, was the reason for statement 3. Because I know that these are equal, EG is equal to the left side, FH is equal to the right side of statement 2, I can plug in EG on the left and FH on the right because of the substitution property of equality. Now, I'm almost there. I needed to prove that segment EG is congruent to segment FH. I haven't quite gotten there yet. I have EG equal to FH right now. If I know that two segments are equal, I know that they are also congruent, because two segments being congruent means that they are equal. So because in statement 4 I have EG equals FH, for statement 5 I can say that EG is congruent to FH because of the definition of congruent segments. If two segments are congruent, they are equal. In this book, They sometimes will give us proofs where we have to fill in the blanks for statements or reasons. They've completed some of this for us. We just have to plug in the blanks that they leave. Something that they do a little bit differently in these problems, I like to tell you to get rid of all of your givens and put it in statement 1 and write your reason given, because that way you're done with it and you know that whatever you needed that you were given is already in your proof. Be careful though, when you are filling in the blanks, completing the proof, you have to watch out and be careful, because like if you look at statement 5 here, it says that ST equals WX. Well, if you look at what you're given, one of the things that you're given is that ST equals WX. So we're not quite there yet, but number 5's reason would still be given even though it's not the first statement. When you are writing a proof from scratch, I want you to get rid of your givens in the beginning. But when you are filling in the blanks, be careful, because they do not put all of their givens in the beginning every time. Using the process of elimination, because on number 1, my reason is given, I know that ST equals WX is going to be taken care of in statement 5. So process of elimination would tell me that my first statement is RT is congruent to segment WI. This also makes sense because if you look ahead at number 2, you have to have that RT is congruent to WI before you can say that RT equals WI. Now, to go from segment 1 to segment 2, I've changed it from congruent to equal. The reason why I can change it from congruent to equal would be the definition of congruent segments. For number 3, we have statement 3, we have RT equals RS plus ST, and WI equals WX plus XY. If you look at what we're given in the diagram to the right, you can see those two segments, and you can see that that is the segment addition postulate. Segment RT is RS plus ST, segment WI is WX plus XY. Because looking at number 2 and then number 3, because number 2 says RT equals WI, and number 3 we have RT equals RS plus ST, I can plug in RS plus ST instead of RT, and I'm going to do the same thing for WI. Instead of WI, I'm going to plug in WX plus XY, and that's the substitution property of equality. So, and that was already given to me. Number 5, we already decided that ST equals WX was going to be one of the statements that we were given. Now, if you look at number 4 and number 5, notice that on number 4, on the left side of my equal sign, I have an ST, and on the right side of my equal sign, I have a WX. Then in statement 5, they tell me that those two things are equal. Because those two are equal, ST and WX, I can subtract ST from the left side of my equal and WX from the right side of my equal sign and just get RS equals WX because, RX equals XY because of the subtraction property of equality. Now I'm not quite there. Again, I have RS equals XY. I was trying to prove that RS is congruent to XY. Because I have them set equal to each other, I can say that they are congruent because of the definition of congruent segments. The next example asks us to write a proof for, we're given the diagram. It also says given X is the midpoint of MN and MX equals RX. We are trying to prove that XN equals RX. Always start, remember, with your givens. So number 1, the given is X is the midpoint of MN, and I'm going to put that MX equals RX. My reasons for my first statement should always be given. If you think back to midpoint, if you know that X is on the midpoint of MN, you know that MX equals XN. The reason why you know that MX equals XN or XN equals MX is because you know that the midpoint cuts that segment into two congruent parts. The reason would be the definition of a midpoint. If you notice my second given, I have mx equals rx, and then I have xn equals mx. We'll notice that both of those are set equal to mx, so I can drop the mx and set xn equal to rx because of the transitive property of equality. And that's it. They asked me to prove that xn equals rx, and number 4, the statement says xn equals rx. The assignment for today is on page 105. It's numbers 6 through 11, 16 through 18, and 32 through 40 even.